Everybody should be able to see my screen. Okay, cool. So we'll keep waiting for a couple more minutes for people to get going and come on in. This is also going to be up on YouTube. So if you have to exit for any reason, feel free. And we're going to send a follow-up email to everybody who signed up for the node-op testing. So we appreciate that. This week, too, we should also have our dashboard up. It's going to display your doc tokens, as well as the additional doc that's been redistributed after the IDO. So we got that to look forward to, just making final touches on there. So, yeah, that should be here this week. You'll also be able to view the NFTs that we had distributed to people who won, our alpha supporters, and also people who did the beta testing for the Docushield app. So we're going to be distributing those as well. In the next couple days, this week or this weekend. We're on testnet right now. Everything seems to be functioning well. So we're just gonna, update all of the core, the mainnet servers and everything, and push the new code up. Just want to make sure that it's all working properly with X Wallet, Zelcore, and everything else. Okay. Yeah, we got one more minute. We'll let people go ahead and join in. Good to see some familiar faces or names. It's been a while, so let's go. Looks like somebody else is sharing the screen too. Who is that? Okay, cool. So for the next part, I'll go ahead and just disable my camera. You guys don't got to look at me the whole time. We'll go ahead and jump right into the Docushield IPFS explained and our node setup intro. So thank you guys again for showing up and coming to this training. First of all, the first thing we really want to do is I want to walk everybody through IPFS. So I know there's videos, online about IPFS, and people try to, explain it. It's a pretty complex, network they got going. And in the beginning, when I was just starting to learn about it, I know every time I did a little research, I just got a little more confused on how it works. And if you guys are going to be participating in the network, first of all, I want everybody to kind of understand on a high level exactly how IPFS works in itself. And then we'll get into how we're implementing it for our private network here at Docushield. We're also going to go into the roadmap for the testing and the implementation and what that means for you guys as far as rewards that are going to be distributed for helping us out, and just the entire future of the network here that we're building. So without much ado, we'll get going. For those who don't know, my name is Adrian Marquez. Very good to be with you guys. We just had our IDO on KD launch probably about a month and a half ago. I think it ended. It feels like a lot longer than that. But yeah, I appreciate everybody who had the faith in us to invest their hard-earned money inside of our vision. And we definitely don't want to let you down. And this is the first part of what we're doing as far as the IPFS network goes. Now, what we're presenting here already is working with our internal team. And, so we got nodes up. We've been testing out the private network itself. We have some nodes up on Flux, who's worked with us, pretty extensively on getting that done. So a big shout out to Flux on helping us out with that. And yeah, man, some exciting stuff. So we're really leading towards a future of decentralization here. So let's get into it. The explanation of IPFS. So what is IPFS? IPFS is a distributed system for storing and accessing files, websites, applications, data, whatever the case may be. Whatever you need to host, you can pretty much put it up on IPFS. Now, as opposed to the traditional Web 2 sense where we all ping a centralized server, to, get our data requests and feed up that information. Within IPFS, we're looking at a peer-to-peer network. So I'm able to get the data that I need from a network of people who are all participating together to distribute this data and make sure that it's always readily available. So there's a lot of big upsides to IPFS. The first one is the total decentralization of data, right? So there's not one place where it's going to be, and if that server goes offline, it's lost. It takes the entire community really to make this thing work. And so when launching a private network, we do have to ensure that we have some stability within that network. So a lot of these peers that you're going to see, that you're seeing in the diagram, they're going to be run by us. They're going to be run by a few other people within the community who are going to be hosting some pretty intense nodes for us. And then all you guys out here who signed up and, want to contribute and get rewarded in the doc token. So it is essential that we have an extensive network to be able to support this and for the long-term stability of the project. So the way IPFS works, and this is just on a high level, we'll break it down in the steps. And this is just general IPFS. Doesn't matter if it's our network, if it's a public network, if it's Pinata, whatever the case may be. So first thing that happens is we import data, right? After that, data gets brought in, it gets hashed out, and then it gets chunked into 256 KB pieces. Those chunks get distributed across the network at random. Our Merkle tree is initiated, and we'll go over exactly what the Merkle tree kind of looks like. And then our DHT table, our distributed hash table, is created. That's kind of like the big ledger that's held in a decentralized way across, multiple nodes that tells the system where everything is. At that point, the CIDs are recorded, and the data gets redistributed, and we'll go over what that looks like as well. Then the data gets fetched, and the DAG is used to reconnect everything. So there are a few things in here like Merkle tree, DHT, DAG that are terms that I wouldn't say specific to IPFS, but are more common in that world. So we'll go over the next few slides what those mean and how they play a part in what we're going to be doing. So here's the way pretty much the storage process is going to work, not only on our network, but for the most part on every IPFS network. Say we have an image right here, and this image is going to get imported through the Docushield app and uploaded right to our private network. The next step is a hash is created for that image, and then that's broken down into a bunch of different chunks. Now, that's all based on how big the image is, but the chunks essentially by default are 256 KB in size. Now, those chunks get distributed after that across the network, and this happens at random, right? So right here, we can kind of see that, a couple chunks were sent to our enforcer nodes, a couple chunks sent over to the Bambino nodes, and, there's a unique identifier behind this, each for the node that it's sent to, and then there's a unique identifier for each chunk that is distributed. Now, so when we reference the DAG in the future, the DAG is essentially a combination of the unique identifier for the node and the unique identifier for each chunk that's created. Now, that helps us put together our Merkle tree. And our Merkle tree essentially just kind of looks like this. Now, every time a chunk is redistributed, it adds another branch to that Merkle tree. And so if things get redistributed like every hour, then you can imagine after a year how intense that Merkle tree would look, right? So after that, when the DAG is created by a combination of those two items, the node ID and the hash, that creates another unique identifier, right? And that is put on the distributed hash table. So we have that unique identifier for each node, and then the keys that link up to the node it was on before. So essentially what this is building is a big list of breadcrumbs. So similar to when you're browsing a web page or you're browsing a blog, and you're going into different directories, and right at the top, you're going to be able to see, you're going in which folder to access, different subjects. So you'd have the index there, and then maybe you have /blog, then you'd have / crypto, or whatever the case may be. So we can always follow the breadcrumbs back to access that file, and we're going to talk about how that happens. So all of this stuff gets uploaded to this distributed hash table, and that's hosted by some of our larger nodes, which we're going to refer to as which is referred to as our bootstrap nodes, right? And so that's in charge of holding pretty much all of this data and allowing us to reference that to climb back up the tree and access that data, which has been composed by the DAG. So the data that we host in IPFS by default gets redistributed every hour. So we have this chunk right here that's on our Bambino node, and node ID number 321. Then it gets sent over to the enforcer, and then it gets sent over to another Bambino. So it constantly keeps moving. And the reason for that is we're not going to really be relying on a single person that's going to be hosting this chunk of data forever, right? We got to keep it moving. And there's some good things to that. Now, there are settings in IPFS that allow us to leave a cache on a network. So, or on a node. So say we pass it from the Bambino to the enforcer goes offline. If we follow the Merkle tree back up, or the breadcrumbs back up, we're going to be able to grab a portion of that if necessary from the cache in the Bambino that it was previously hosted on. And if not there, then so on and so forth. It has a few different places to try, right? So we're not relying on just one person to have this data all the time. And if they go offline, we're never going to be able to access any of that. So the data gets redistributed every hour, and we can adjust that within the settings of our network and fine tune it, see what works the best for us. And then the data gets fetched whenever there's a call made. Now, the fetch pretty much calls back the last known place on the tree for each chunk, and then almost reverse engineers it, right? So we have all of these little tiny pieces that get followed backwards, and we're able to recompose that from by following the breadcrumbs back up now that are linked to the hashes. So by the time we get to the very top, we have all of the pieces that we need to recompose this file and deliver it out to the public or whoever is going to be requesting that in our case. So that is a quick overview on how IPFS works as a whole. That's not only specific to our network, that is pretty much just how IPFS is set up. Now, if there are people out there that are, true hardcore IPFS heads, and I'm definitely simplifying things too much. So for those people out there, if you want to have a conversation or anything further about how it works in detail, you can always contact us. But I really wanted to simplify things to make it easily digestible for everybody. Because I know my first time around, it took a while to really comprehend how everything worked. So the next thing we're going to talk about is node categories. And this isn't really the categories that the node setup is going to be on. So nodes are referred to a few different ways. Now, the categories really are representing the functions that are performed by the network. So each of those functions that are performed, they get separated into three different categories. And the first is the IPFS infrastructure. So these are all of the calls and functions available by the main infrastructure, right? So the main infrastructure is developed with Go or JavaScript instances of the IPFS server or node. It also consists of the API that we use to interact with any other platform. It consists of the administration at the administration level, pretty much all of the different orders and all of the orchestration of what's going on in the network. So it's in charge of telling everybody, who's doing what, and it plays pretty much the admin of the network. This is also the IPFS infrastructure, gives us the ability to assign tasks to other people. Now, when we're creating a node, a customized node profile, we could take any one of these, any combination of these functions, and combine them into one, custom node itself. So we're just really separating the functions out right here. Next are the data functions. So the IPLD, actually the data chunks, and it stores it in the block for each node. So that's the process of actually storing. The Unix FS is the data distribution service, our structure. So data nodes handle the structure of how the data or data functions anyway, control the structure of how it's distributed. It builds the DAG for our file reconstruction, and also for combining the node hash and the content hash. And then it creates our Merkle tree with composing of those hashes as well, created by the DAG. Now the data node also can maintain the DHT. That's part of the data functionality. So that distributed hash table. And all of these items are composed of some type of storage mechanism, right, that we're going to need. Now we also have the peer-to-peer category, the libp2p. This gives us the functionality to execute peer-to-peer tasks, listen, and dial on requests. So if the Bootstrap node sends a request out there for me to grab or listen for a certain piece of information or a certain chunk of data, that's exactly what I'm going to do with the P2P functionality. I'll take that call and I will get ready to host that chunk of data that's being delivered over to me. So this is also used when connecting to peers for persistent data. So persistent data is stuff like, a website, a type of database, or anything like that where we need some consistency within the platform. Now, there's a lot more functionality that is included with this, but these are some of the main functions. Now, like I said, when we create nodes, that could be they can consist of all or of just a few of these functions, right? So there's all kinds of custom built nodes that are available, and we're going to start off with a few of them broken into different types, right? So we'll go over these the way that IPFS refers to them. So the first type of node is our Bootstrap node. The Bootstrap node is the system admin or the orchestrator. It's always ready to take in any content and distribute it, to do whatever needs to be done to ensure that the network is properly running. It maintains the DHT table. It's a Go or a JavaScript implementation. And what's really important about the Bootstrap node is it must remain accessible. So if it's going to be the orchestrator behind this whole deal, then it has to have a required uptime, right? Or else, you have a whole team of people with nobody leading them, essentially. So the Bootstrap is going to be one of our main focuses. And when we get into testing, pretty much everybody at the start is going to be a Bootstrap, and we'll get into how we're going to segment people later from that. But there are, next, we have the preload node type. So the preload gets the data ready for serving it up on the web, right? And anytime it's called, the preload just is available and ready to display that information. So it exposes the API, and it allows us to query the network in case there's a loss of a Bootstrap node. Okay, and I think we got Corey giving us a little feedback. If you could mute yourself, bro. Thank you. Appreciate it. Okay, it exposes that API to query the network in case one of the Bootstrap goes offline, right? So this is kind of the second in command. It's going to be the backup for the Bootstrap. It has its limitations. Like it can't write to a DHT table, but it can query one if it needs to. The preload will host the data chunks on their blocks, and this is in a randomized way. So the bootstrap is going to be helping orchestrate, where that data goes. And once it's assigned, it's going to use the preload mechanism within, or the preload node, to actually store that information on those blocks for an hour, for 2 hours, however long we decide. So they can only query the DAG and the protocol buffers. So again, the preload doesn't really write anywhere, right? It can just query and see where the last location of certain chunks were if the bootstrap goes missing. So this is kind of the backup man for our preload. Now we have then after that the routing node. Routing is, in the absence of a bootstrap, can query the DHT and push the content and run the logic. So there's a difference between the preload and the routing, and I'll go ahead and explain with an example. So say we have the bootstrap would be just if we have a super beastie computer, right? Has a lot of processing power, has a lot of storage, and it can kind of handle anything that the network throws at it. Now, the preload node would be used in an instance where we don't have so much RAM and so much power behind there, but we have a lot of storage. So a lot of servers will have like less threads or less cores on them, and maybe less RAM, but they have more storage capability. That would be more suitable for something like a preload node. Now, the routing node would be kind of the opposite. If we have a lot of processing power, but we don't have much storage, I think in the absence of the bootstrap, it would be more suitable for the routing node to step in and, pick up those assignments that have a lot of memory requirements and a lot of logic that's going to be run on the back end. So they're more capable for that rather than storing, data chunks in the blocks. So a lot of the times these two are paired together, right? The preload and the routing, they'll make one node. But like I said, if we have a system with specs that, are more suited for one or the other, then we're able to dedicate one as the routing, one as the preload, and that essentially will make them run more efficiently. Now, the next one is kind of the most exciting one, even though it does the least, and we'll get into why. So the relay digs a TCP portal in the absence of the Go or JS system persistence. So there's two different types of nodes, as we discussed. They're implemented in Go and they're implemented in JS. Now, those don't really communicate with each other or reference each other very well. So there has to be somebody in the middle to facilitate those communications by essentially tunneling between the two networks, between the Go and the JS instances. So the cool thing about this is it doesn't really take much power, processing power, and it doesn't really take much storage capability in order to run a relay node. The way we can kind of envision it is there has to be, say there's a wall in between the Go and the JS implementation, right? And there has to be a window put in there in order for us to communicate in between the two. So Go's on one side, the JS network's on the other side, and we have to have an open window for communications to the relay, right? Now, so there has to be a middleman there keeping that window open. That would be the relay node. Now, if that relay node shuts down, goes offline, then there has to be somebody ready to take its place, or else we're not going to be able to query the other nodes for information on the other side that we need. So we're essentially with the relay nodes going to be forming a line, right? So this is my favorite because it allows us to do stuff like create one of these node types on something small as a phone, on an Android that could be run. And essentially all it's doing is it's going online and waiting until the call is made and they need somebody to step up and keep that window open to middleman those communications, right? So we're always looking for somebody, if there is a lack of communication, to help us middleman the communications between the Go and the JOS instances. That really helps with the system persistence overall. So they're really easy to run. And, in the future, we really want to give this ability to people to run just on their phone. So it'll keep listening for a call when it's needed to keep this window open. The app will go in and fulfill that, right? And, it's a small role to play, but it's a very vital role to play in having a network that's pretty much ready for anything, right? So the bootstrap, to start again, the bootstrap node does everything. He's the big man, the orchestrator. He tells everybody what to do. The preload node is used to serve up the data and acts as a backup for the preload. The routing node also acts as a backup for the bootstrap, but it acts as a backup in a different way, more running logic and pushing out assignments instead of just serving up the data. And then the relay digs that tunnel in between the Go and the JS instances and allows us to maintain a persistent network by keeping that middle ground for communication open. Okay, so I hope that was all pretty clear. We'll move on to the next thing. So now that we understand the different kinds of node types there are, in a general sense, how IPFS works, we're going to go through our roadmap that we have for testing. So the first part is the introduction, which we just went through, and the training. So after this is over, in probably a couple hours, we're going to be sending out an email that has all of the documentation that you're going to need to get started on our network. So we're going to be doing the implementation of that private network with more peers. That's why you guys are here, because we've been testing it now internally with about 10 of us, and we're going to get a lot more information when we add more people to that network. So once everybody's added on and we start onboarding people, we're going to update the nodes with a logging agent, right? So that's going to be installed on your machine, wherever that node resides. And that's going to allow us to analyze the data. So it's going to feed back information to our server. We're then going to analyze that data using, some tools that help us graphically structure everything and identify when certain things happen. It's going to allow us to set alerts on certain items, like when a node goes offline. If we want to set an alarm for that, if it's a bootstrap node, we're going to be able to start doing that stuff once we start getting that data back from all you guys. After that, we're going to be stress testing the network with data loads. So we're going to be pushing tons of content up and just seeing how it persists with everybody. And reminder, at this point, everybody's going to be a bootstrap node right now. So everybody's trying to do everything at this point, which allows us to really see what machines are able to handle that, right? So by reading those logs. So after we get all that data of everybody being, a bootstrap node on our network, some people are going to struggle more. Some transactions or actions are going to fail because some machines just aren't well equipped to do some of the things that a bootstrap node's set up to do. So that's going to allow us to take that data and segment that into our user profiles. So we're really going to be able to see, what tasks are well suited for which implementation on our network. And then we'll be developing these custom profiles based on, what we put out in our Medium articles. So 4 different types, all segmented by, their strong suits. So we really want to see where your machine's performing well, and we want to act on that. And that's only going to do, well for our network when everybody is being utilized for their strengths. So after we segment everybody into those different profiles, we're going to finalize a reward structure. And this is something we've been, kind of pushing back on, only because we need that data and we need to see all those processes happening in order to put a weight on, on the value of each of those processes and reward people according, to the value that they provide to the network. So this is really going to help us once we start getting all that data and start analyzing it. It's going to help us define that reward structure and be able to put that out in the public. So we've had some ideas of how we want to do it, but it's all up for debate still right now. So working with our tokenomics and working with the feedback that we get from the data that we collect, that's going to help us achieve that. Once the reward structure is finalized, we're going to be doing the final implementation of our front end graphical interface. So right now, with the network, it's going to be using the standard IPFS GUI that you're going to be able to download. You can also participate, in your command line, which is you're going to find instructions for in the email that you get following this. But if you want a nice, easy GUI, that's going to be available from the start. I don't want to make it too difficult for everybody. All the time, while we're analyzing this data and everything, we're going to be building our own custom front-end GUI. That way we know exactly what we want to display there as we're working through these, and we're going to feed back to you guys the best information and the most relevant information that's available. So after that, it's going to be time to pen test the network and prepare for mainnet. So one more time, we're going to try and just stress test everything by loading tons of data through those channels that we're going to be using, serving them up to the public, and we're going to be consulting with some outside security professionals to kind of help us stress test, help us penetrate test that network, or penetration test the network, and make sure that we are ready to host all of this data that's given. Now, on our internal tests and everything, with what we've been running, everything seems to be working fine. Everything's great. The encryption methods are working. Everything seems to be going well. So, that's good. We just want to make sure that as we onboard people, that, that remains the same and that the network has stability. So right now we're in the introduction and training. We'll distribute the guides after the meeting today. We're then going to begin the implementation. That can start as soon as today if you guys want to onboard. During that process, we'll have people manning the Discord and manning the Telegram. If you guys have any questions about or any issues getting things up, we'll be able to help you out. After that, we'll be updating the nodes with the login agent, analyzing the data, stress testing the network, reanalyzing that data, segmenting everybody into the profiles based on what's going to be best for their use case with their machine, finalizing that reward structure, implementing the front end, and then one more big penetration test. So just wanted to go through that one more time for our roadmap. And what we need from you guys. So it's really important that whoever's going to be participating does stay involved. We're going to need some dedicated uptime as everybody's acting as a bootstrap in the beginning to allow us to really properly analyze how the network is responding to your machine and what processes your machine's performing well, which ones it's doing performing not so well, or whatever actions are failing. We need that dedicated uptime to be able to read that. So we're going to have those requirements set. Once we start analyzing the data, if we notice that there's not the uptime that we need, we're going to reach out to you and let you know. And if that keeps happening, you keep going offline, we're going to remove you from our peer network. We also need weekly feedback. So for everybody who signed up, we're going to be sending out a list of questions. It's going to help us with our research from our end. And it may be some instructions like, a new file to add into a specific directory or something like that. So we need you guys to kind of stay on board with us and perform those tasks and give us that feedback. We're going to need permissions to read your system logs. So if you're using this straight on your regular desktop, that may be a concern to you guys. So you may want to, partition a part of your machine to strictly run, an IPFS node, if that's a concern of yours. All this information that we gather is going to stay in-house and here on our network, and we're only going to take the relevant information. And when we do deploy that user agent or that login agent, we'll let you guys know and put out documentation as to what exactly the information we are collecting is. So we want to be really open with that, not trying to collect anything too personal from you guys at all, but we need that information to see how your system's interacting, what resources are being used, and how much more pretty much your machine can take in supporting the network. We request timely responses to the requested tasks. So we'll be reaching out to you via email, and we're going to be asking for maybe your Telegram or your Discord handle. That way, if it's another way to reach out to you. Again, if we can't reach you, we can't get in touch, we're going to remove you from the network, just so we have the people on board that we're actually getting that valuable information from. So failure to participate will lead in the node being removed from the network. Our Discord is where you're going to go in and actually submit your peer ID that is going to allow us to track who you are and what machine you're transmitting from. Along with your peer ID, we're also going to get your wallet address for future rewards that are coming through. So that leads us to the next part, what you'll get in return for helping us out. So we are going to segment an allocation of our DOC token at token launch to distribute against everybody who's participating. We don't have a set amount yet, but we will be announcing that in the future. What the specific allocation is going to be, that's going to be announced after we work out the tokenomics for the reward system. There's going to be a surprise NFT that we're going to have to give you guys continual benefits on our platform and some partners platforms and other apps that we develop in our ecosystem. And we got some pretty exciting announcements coming soon about other projects we've been working on as well. Special pricing on all products in the Doc ecosystem is going to be given to anybody who participates as well. The NFT is going to reflect a lot of that, and more to be announced. So, we really appreciate your guys' continual support and feedback, and we definitely want to reward you guys in turn for helping us do that. So, one of these things is just cool. We want to give the gift that keeps on giving. So, giving that surprise NFT. We're going to keep utilizing and keep adding, different rewards to it. Now, that is pretty much it. Now we're gonna leave it open for questions. If anybody has any questions on how the network works, if you didn't sign up and want to participate, if you have a question about that, let us know. But I'll open the. I'll go ahead and open the Telegram real quick. Any information on the timeframes for each stage of this roadmap? We have our definite date of mid-September, where we're going to be going from beta to transitioning over to our mainnet. So there's not a definite time that I want to put out, or any specific dates that I want to put out, because we never really know what we're going to run into. That is essentially just the roadmap that we're going to follow. So we're straying away from putting out specific dates, but trust, we're working on fine-tuning that logging agent right now that we're going to be deploying. And we're also working on customizing these profiles and being able to set them the way that we want. So we're well on our way, and we're not starting from ground zero on most of these tasks at hand. But great question. Okay. Do any of the updates affect the release of the token? Nope. The token's being released October 1st at the latest. So no, nothing is going to affect that. And by then, there will be a use for our tokens. So the AMA is recorded, I assume. Absolutely. AMA is being recorded, and we're going to upload it onto our YouTube after that. Okay. Are we able to run multiple nodes during this beta phase, not specifically for rewards, but to further help beta testing and provide a wide range of resources? Absolutely. So please, we do encourage you guys to do that. Just we'll talk to you guys in the Discord when you link up your peer ID the first time. And if you want to add another node, it would be a great time to bring that up, and we would definitely appreciate that. All right, Thou. Yeah, like that video. Will there be a maximum number of nodes allowed to be run per IP? That's actually something we want to further analyze as well. So being able to log everything that's coming from the same IP. Since we're going to be using the peer ID as an identifier along with a unique string that we're going to be generating, no, I think it'll be fine, for you guys to run two on one from one IP address. That would allow us to see too if there's any consequences that we didn't anticipate from doing that. Will the server running a doc node be able to run other stuff if the resources allow it? Yeah, absolutely. So the only thing that all of us right now, pretty much in the office and stuff, and people are participating at home, are running it just on their regular, installed OS. So we have people running it on Linux, Mac, and on Windows. So yeah, definitely you'll be able to do that. The only concern for you would be when we start logging all of that data, what you want to transmit to us, but we're going to really limit the information that we're logging and sending over. And like I said, we'll be transparent about that as well. Can nodes be run in VMs or require bare metal servers? Nope, they can be run in VMs as well, and they can be run in a container if you want to go that route. We're in the middle right now of actually building a custom OS, a Linux-based OS right now that is going to allow you just to kind of mount that OS anywhere, and boot it, and then participate in the network right from the go. So that'll be just a custom Linux distro that we're putting together that just runs the Docushield node. No bloatware, no anything else. Just the raw OS just for the IPFS. Okay. DocTube, I love it. Hold on, look. I think I missed somebody. Okay, email is a part of the Docushield roadmap. What about a messaging app? That would be a way to communicate with node operators while testing. Don't want to give away too much. Whoever that is, redacted, you must be part of our team, because we're working on some stuff like that. But no, not at this phase. We're not introducing any of that stuff. We're really focusing just on the node ops. That would be cool if that stuff was ready right now, but we don't want to get ahead of ourselves. We're going to tackle one big chunk of things at a time. We're just getting started, and we got a long road ahead of us to tackle all of those things. So great question. And yeah, if you know anything, then please just loose lips sink ships. What about Docker? Docker, yeah, that's going to be an option. We're gonna have a Docker container that you're going to be able to pull down and utilize as well. We actually have one right now, and that's how we're launching on Flux. So we have a few bootstraps loaded up, and yeah, they're referencing the Docker image, and that's how Flux connects with our network right now. Did I miss this? What are the main system specs or OS requirements, Corey? Right now, there's not any. So we really are onboarding anybody who wants to participate, and that's going to allow us to see, what exactly the requirements are. So based on the participation, we're going to be custom building those profiles to a deeper level. So right now we're onboarding anybody. You can use an old laptop, an old machine. You can use a server. You can use a VM, whatever the case may be. When you do sign up, though, or when you do get onboarded, we want you to be transparent. If you're not, when we get the logging agent installed, that's going to show us either way. I heard Doc Ecosystem. Yes, sir. We are working on quite a few things, but yeah, so sometimes we got to rally ourselves together to focus on one, but Doc Ecosystem is in the works right now. Though IPFS network is our main driver. So also the app is well underway and into its redesign and into the back end development, getting ready for mainnet. But Docushield app is what we promised, and it's what we're going to deliver first. Then we'll start introducing more aspects of the ecosystem. If your computer has a turbo button, it may not be suitable. We'll see. We'll find out. A turbo button. It's like nitrous in your computer. If you have a custom Linux OS, would that preclude us from running other nodes on the same machine or VM? Yes. So that custom build that we're working on is going to be just for running IPFS, utilizing all the resources provided by that machine or that container or whatever for IPFS. So that would be an isolated instance, and you wouldn't want to run anything else on there. Can these nodes be run on a VPS instead of your home machine? Absolutely. Definitely can. Any collateral needed at this time? Nope, no collateral needed at this time. So you'll just be able to join on in. We're going to ask for your wallet address, like I said, and we'll later connect the two. Can mobile phone be used to run a doc node? Not yet. I mean, that's something, like I said, I'm really excited about, and we're definitely going to be working on. But that's definitely later down the road after mainnet. And that'll be cool just to have something for you to keep running in the background and earn rewards while your phone is just listening for commands from us. Any requirement for internet up and down speed? At the moment, again, we're not being too picky. I mean, if it's really low, the up speed or the down speed, we'll reach out to you and say, hey, maybe you want to restart your router or something like that, to see if it's just an issue with your network. We'll be putting more strict requirements after we gather all this data. Any location restrictions? No, not at all. So unless you're somewhere that doesn't allow you to connect, I know that China may be an issue. And we still have, one of our members who is in China participating as well, but, jumping through a few hoops. So that would be the only location restriction I could think of, but I don't know if there's any other places that do that as well. Why did you choose Kadena Chain? For Pact. For Pact and the power behind it that's going to help support the security of our network. There's a lot of things in Pact that aren't available anywhere else. And in particular, we're utilizing guards as another way to be able to, keep everything safe and shielded from anybody who you wouldn't want accessing those documents. So again, just the versatility of Pact and the power behind it is why we came over here. And also proof of work. True decentralization starts at proof of work. Decentralization at its core is another reason we chose IPFS as our host. Let's see, like Pi Network. Yeah, very similar. Very similar. There's a lot of networks out there that are based on IPFS, but we are definitely doing things a little bit different on our end and custom tailoring it to fit the needs that we require. As far as data security and accessibility. Okay, I'll go ahead and stay on for some other questions you guys may have. Let's see. Edward, voice is not clear. We get half of what you're saying. Damn it, I'm sorry. I don't know if it's my connection, but I'm hardwired in. Maybe the YouTube version will be a little more clear if it's an issue on your end. But we'll see. If there's anything we need to verify though for you, man, let me know. How big is the Docushield team now? And just for the record, are you guys full-time, part-time? So yeah, we have a combination of full-time and part-time. The full team is with full-time and part-time, and our moderators in Discord and in Telegram are about at like a little under 20. So I think we're at 18, 19 with a few contractors in the middle there, and our Telegram moderators and stuff. Full-time people, we have, I'd say about, let me count in my head, probably about 8 full-time, constantly working on Docushield and thinking about nothing else. Okay. Sound has been fine all the way through here. Thank you, Christian. I got a little bit of a raspy voice. I did a test one of these presentations yesterday with my team, and I was talking to our, to my lead dev last night till about 3 a.m. So I'm a little beat right now, but sorry about that. But yeah, I'm glad everybody else has been able to hear. Is document signing, for example, real estate offers part of the vision? Definitely. And as we dig further in to NFTs and the content verification services allowed by Kadena and by using the Marmalade standard, then we're definitely gonna be onboarding more of those ideas into the application for document signing, verification, things like that. Oh, can it run on Mac OS? Absolutely. You'll get instructions for running it on a Mac. Do you have plans for auditing the project and the team members? I audit the team members pretty regularly. So yeah, they're probably sick of me auditing them. But the project, yeah, I'm open to an audit, definitely on the code. Right now, our code is private. It's on GitHub though, but as we're working through this and until we launch, the code is going to remain sealed up for us, just as a business decision to keep things proprietary on our end. We've been working really hard on what we got going. So yeah, that's a business decision. Whether you agree or disagree, let me know, and we can have a conversation about it. But it is, what we decided to do. Will the how-to for dummies be a simple guide for us noobs? Yeah, man. I hope this was a simple guide into IPFS. That was the goal. Now, the guide for launching that we're going to be sending out today to joining the network is definitely simplified. I mean, it's very easy to understand with not much technical know-how. And if you do need some assistance, then you can reach out to us on Discord and Telegram. Third party, yeah. Definitely open for a third-party audit. Sure. The code is definitely going to need to be audited as well for our smart contracts. So definitely an important part of the process. And we're going to be reaching out to some people who can do that, but a lot of there's not much experience in the realm of, the PAC language right now. So who we turn to for this audit is, a question in itself. And once we get to a version that we're satisfied with to present for auditing, we'll go ahead and do that. Before that, we'll have to get the research done. Can you use a VPS? Yes, absolutely. Optimal system bootstrap, sustained. We're gonna let you know. We're gonna put a range on that, and present that when we start onboarding people. After we start, getting those logs sent over to us from everybody. Will I be able to run doc nodes on my Flux nodes? So, great question. You're going to be able to help support the doc network while running a Flux node, right? We'll be utilizing Flux as an endpoint for some of our communications. Now, you also separately would be able to sign up with Flux and host a container that has a doc node inside of it. So, yeah, that would essentially be running a VM, but it's a container. The same thing, but you're hosting it on Flux and you're participating in the network. Now, an actual Flux node will be utilized, and we're going to be linking up with the Flux team to further develop the rewards distribution for the doc token for people that are running the Flux nodes. So if you're a Flux node operator and you're supporting our network by being dedicated to the Docushield network, you're also going to be rewarded on top of the Flux that you're going to get with some doc token that we're allocating. So we'll put out more information as we work out the finer details with Flux. We just got past, the implementation of the IPFS on Flux. So the next thing we do in our partnership with them is work out the tokenomics behind the reward structure that will be presented by them. Does that mean there will be additional benefits if you run a Flux node? Yep, definitely. So if you run a Flux node and you're participating in the Docushield network, then you're going to be getting Flux and Doc for your services. Okay, as KDA rewards are rewarded if running a KDA node on Flux. Exactly, right. Yeah, exactly the same way. I think Mock's doing the same thing. If you're supporting the Mock network, then they're also distributing some Mock token to the Flux node operators. So, definitely trying to follow in the footsteps of some cool stuff that's going on just like that. So was this answered? Doc collateral isn't required. Yes, that was answered, but no. No collateral is required to get started while we're in the testing phase. Now, as we roll out into mainnet for the new people that are onboarded, there will be some collateral requirements. But for everybody who's in testnet, if you want to remain a participant, then we'll just keep you on without that collateral as a token of our appreciation. Okay, great questions, everybody. I see some people are still typing, so we'll hang on there. Have you selected a DEX yet? Yeah, I mean, we're definitely partnered with with KD Launch, who helped us facilitate the whole IDO, and has been a big supporter of us the whole way through. And besides KDL, by the way, who just put USD up on their exchange. So if you guys haven't heard about that, you now have we have a stable coin in the on the network. So if you want to get that, swap out some KDA for some, I think they call it KD USD, then you would go over to kdswap.exchange and do that. And that's where we plan on launching our token sales at. Got it. Thanks for the AMA. No problem, man. Thank you guys. When Lambo, I don't know, man. Never for me. I can't see myself spending that much money on a car. That's ridiculous. Yeah. So, yeah. When Forerunner. All right. Adrian's greeting from Thailand, 2 a.m. here. What's up, man? How's it going, man? Thanks for joining in, man. Staying up late. Appreciate you joining. Sorry, voice is raspy, a little less energetic than usual. Super tired, but feeling great, man. I'm very excited about the progress we've been making, and great to see you, Ben. What's the difference between Filecoin and this project? There's not going to be crazy requirements to participate. We're allowing everybody. The barrier to entrance in our network is going to be low. You don't need to have a supercomputer, which is, one of the downsides of Filecoin. And on top of that, everything that is going to be on our network is going to be encrypted. And those CIDs aren't going to be visible from the outside world. So as opposed to Filecoin, which has a public network, you can see the Explorer for their Merkle tree and for all the blocks that are, being used. So none of that stuff is going to be exposed. Our network's based on security and privacy. So great question, Frank. Okay, cool. I see we've still got people typing, so we'll stay on the line. Let's see who else we got online. Do some shout outs. Last time we seen Thao was his birthday. It's probably it's a bit from there now. What's up, Thao? Rizgar, what's going on? Micah, welcome. Matthias, howdy. All right. Let's see who else we got. Okay. Yep. Time to moon, baby. All right. Thank everybody. I want to thank everybody for tuning in. If you guys got any questions, you can reach out to me directly, myself, or you can reach out to our team. The best way to reach out to me is going to be through Telegram. Discord, I just don't boot sometimes. I just have too much stuff open. So if you have a question for me directly, you can contact me right here on Telegram. You can get support for any of the things that we're going to be moving forward with, especially in the testing aspect, with our Discord and in our Telegram. Sign up instructions are going to be going out today. And again, thank you guys. Frank, Telegram handle. There we go. Chemo got it for you right there. AM_Docushield. Thank you, Chemo. Thank you. Looking forward to this project. We are too, man. We are ready to get this thing going. It's been what's felt like an eternity, but I think it's only been a couple months. But yeah, very happy with the progress, man. Thank all you guys. Kalina, what's going on? Okay, so again, I'll remain available for any questions you guys got. Just feel free to connect with me. If I don't get back to you immediately, I will get back to you at some point. Just want to put that out there. And thank you guys for your continued support. And big shout out again to KD Launch and KD Swap, who just put out that stablecoin. You guys go swap out some of your KDA for some USD. Our network's growing and getting stronger daily. Great to see. All right, everybody. Have a good one, and we will talk to you soon.